Good morning, everyone. We are Group 5, and today we will presenting our project on construction of real-time monitoring system for sport cruiser motorcycles using NB-IoT and multi-sensors. Our team consists Griffin, Reza, and Bismarck. And this work was guided by Mission Eden Christiani, Professor Tazu Hu, and Professor Cha Tung Yang from Tunghai University and Krida Bankana Christian University. Our project is aimed to design a real-time motorcycle monitoring system using NB-IoT technology and multi-sensor to improve vehicle safety and data accuracy. In this, the NB-IoT Narrow Internet of Things. NB-IoT is low-power wide area network (LPWAN) technology developed by 3GPA. The 3GPA stands for Third Generation Partnership Program. It is a group of company who make standards for internets. It provides wide range coverage by using low energy use and stable communication for IoT devices. The NB-IoT operates on a narrow bandwidth 180 kilohertz. The key feature of its work on pre-existing infrastructure as 4G LAD. It has strong signal penetration suitable for underground and remote areas. They can connect a large number of devices with minimal power, provide reliable data transmission even for a device that move for speed such as motorcycles. And in next, NB-IoT in motorcycle monitoring system. In the research, NB-IoT act like a main communication link between motorcycle sensors and cloud servers. Sensor detect data such as voltage, vibration, temperature, GPS location are sent in real time using MQTT. The key benefits in this system are they provide stable data transmission even when motorcycle is moving. They ensure low power operating suitable for vehicle battery. They enable real-time monitoring and instant alert through a cloud by taking help of MQTT protocols. They make cost-effective and reliable for long-term use. Now I call Raisa.
Okay, the next one is the types of the IoT. In this paper, the types of the IoT that been used is LP1, which means it's a lower power wide area network. This LP1 is one of the category of one wide area network, so the system directly use one networks. The system is use one networks because it must send the data from the motorcycle traveling over a wide area like a city streets, mountains, and between regions to a central server in real time. The IoT device, it uses sensor on motorcycle like a vibration, temperature, GPS voltage, and the data it will send to the cloud via an NB-IoT cellular network for remote monitoring. Okay, the next one is the comparison with the other LP1. So before they choose the NB-IoT, they try to use LoRa and Sigfox, but LoRa it's simple, range and structure, but there's a limitation on downlink and idle time after transmission that can interface with certain operation. And the next one is Sigfox. It's very low throughput, limited payload, and no reliable confirmation mechanism, and limited by a duty cycle, making it less suitable for dynamic monitoring needs. And so at the end, they choose NB-IoT because NB-IoT as a 3GPP standard, it has compatibility with cellular infrastructure, better coverage, and transmission stability. The journal states that field test results show that NB-IoT can maintain stable transmission on high-speed lines, so it was chosen as the main mechanism. Okay, why they choose NB-IoT? Because NB-IoT have a low power consumption, enable long-term operation without frequent battery change. The next one is the wide coverage. Use existing LTE network infrastructure. And then the next one is high reliability, stable even during high-speed motorcycle operation. And the last one is cost-effective. We use cellular networks and lowering development costs. Next. And there's a NB-IoT key features. There are several key features. The first one is narrow bandwidth. It's around 200 kilohertz, and then the data rate is around 16 until 62 kbps, and then the deep door signal penetration, and it supports EDRX and PSM for battery life extension. And then the last one is ideal for small periodic data packet from sensor. Next will be explained by my friends.
Okay, so the next part is about MQTT. In a nutshell, MQTT or Message Query Telemetry Transport is a lightweight messaging protocol based on the public or subscribe model designed to cope with low bandwidth and unstable network environment. Its core component includes publisher, which are responsible for sending messages to specific topics, subscribers, which are responsible to subscribe to this topic in order to receive email, and MQTT proxy servers, which are responsible to receive message from publishers and distribute it to subscriber without direct interaction between publisher and subscriber themselves. Also, there's a bit of a note about MQTT. The MQTT library itself implement MQTT process by providing an interface between client and proxy servers in which the publication of its message contain a payload, where the payload itself is a custom data sent by the publisher to the proxy server. These messages are diverse and contain a variety of data types, from sensor readings and command to important status update. In this project, however, the message sent by the MQTT are transmitted in JSON format, which provide flexible and structured data expression. So how MQTT work in this project? Well, as you see, sensor at the sensor and actuator layer, the system we use in the project is to focus on capturing real-time operating data using variety of sensors. Now, the integration of these sensors, such as GPT and vibration sensors and etc., not only provide an accurate source of data, but also lay foundation on the subsequent data analysis. This process is handled by data processing and transmission layer, which use Python for data cleaning. This layer, when combined with, of course, with the previous mentioned NB-IoT technology and MQTT protocol, not only achieve efficient data transmission, but also ensure smooth data communication between different models. Of course, to improve the system adjustment frequency, we introduced MQTFX, which is a software or app as a key client tool for MQTT protocol to focus mainly on the system adjustment phase, providing intuitive interface to monitor and analyze MQTT message flows in real time. Besides MQTT-FX, there are several software or app we are used in the project, such as Mosquito, which are an open source message broker that implement multiple version of MQTT. Its high portability allow it to be used on a variety of platforms. To facilitate testing, the Mosquito project runs a test server to test client under different environments, including TLS encryption and WebSockets. Overall, the combination of both MQTT and Mosquito provide a reliable and efficient data transmission solution that is suitable for this study requirement and low power consumption. And of course, there are my SQL, which are related to Python. And of course, Python itself plays a key role providing comprehensive solution for data collection, processing, analysis, and storage. Now, a lot of this process doing by Python, including exchange data from Mosquito, will be processed and uploaded to MySQL database via the MySQL connector library. And the last software we are using is Grafana. This software is selected as the key tool for data visualization in the study support, at least in this project. This software has a highly customizable interface and compatible with variety of data source, including MySQL database. This allows to obtain real-time data directly from the database and display the vehicle operating status through line charts, dashboard, maps, and other methods. So basically, the main function of Grafana is to optimize vehicle operation and tightive strategies for individual users, which send alerts to in the event of abnormal inclination or suspected thief. As for the next part, I will present it to my friend Nathan.
Right. Next up, I will be explaining a little bit about the implementation in the motorcycle monitoring system. As previously mentioned by a few of my friends, it is a long process. There's multiple applications that I use. There are multiple sensors that I use, even line notified for alerting your phone. So for the implementation, it uses as the main data transmission of the channel. It works together with MQTT, public subscribe messaging, and it also sends sensor data in JSON format to a cloud-based SQL database. It ensures real-time updates of speed, voltage, and location integrated with the HANA dashboard for live visualization. Its alerts are generated by line to notify anomalies. As you can see on the graph on the right, there it actually provides what the app will look like. The sensor will alert, and then it will send it to the NB-IoT, which will be going to the mosquito, and from the internet it will go to Python. Now for Python, I will go to MySQL for the data processing, and Grafana will give the display, which I will show earlier, which then goes to the computer, and so the data is stored. Next, other than that, Python also goes to line notify, which gives an alert on your phone, and we'll show again later. Next, please. Now, this is the system architecture summary. For the sensors, they are right here. There's a temperature sensor, there's a vibration or gyro sensor, there's an IMU, and then also there's an IMU, and also a GPS. Right here, you guys can see it's ESP32 MCU or the NB-IoT module right here. We have the MPTC broker, so Mosquito, MySQL database, Grafana, and so my Now, these are the visual data. As you can see, Grafana provides the data of our motorcycle in a very detailed way. It shows us visualization of speed, placement, fuel, and etc. It also sends the line alert example from the graph that I showed earlier. As you can see right there, it notifies us that the vehicle is moved abnormally in coordinates such and such. And for the vehicle installation, as you can see right there, there's a few, there's an OLED display, infrared temperature sensor, systems, and then many, many more, like shock sensor, GPS module, buzzer, and communication modules. Next. Now, these are the key achievements. The Grafana graph I showed earlier is a little bit too small. This is the bigger version. It basically shows everything about the motorcycle: room temperature, water tank temperature, humidity, and etc. etc. There's just a lot of data that is being displayed through Grafana. There's also stable data transmission in urban mountain and highway environments. You can see there's a map on the bottom left which shows the materials and the average room temperature. There is it shows like the change the engine oil change maintenance to add cool, and then also the path that a motorcycle has went through. And then next is enable immediate alerts and data driven decision for safety. Please next for the visualization. And there it is. This is the alerts that is sent to by Notify. For example, right here it says warning, vehicle angle limits are greater than 65 degrees for more than 3 minutes. And then it shows the coordinates. There's many parts that are being shown here. I'm not gonna mention them all by one, but it basically shows a lot of notifications depending on what the motorcycle is experiencing. Next. So I think that is all from us. Thank you for watching, and I'll see you next time.